Hi, in this video I'm going to go through MAT 2023 question 3. So, without differentiating, write down the maximum value of cosine 2x plus 30. Quite a straightforward question because we should know that cosine takes values between 1 and -1, so the maximum value of that function is 1. Again, part 2, without differentiating, find the maximum value of this. So what I'd instinctively want to do here is make a little substitution. So let cosine of 2x plus 30 equal, I don't know, u. So what I've got is u times by 1 minus u, which is u take away u squared. Okay. Now, what I could do here is differentiate it and find the turning point, or better yet, if I've got negative u squared plus u, okay, I could complete the square. Okay, and if I complete the square, what I get is, if I factor out the negative, so u squared, take away u, I get negative, remember how to do this, u take away a half, all squared, and that's going to be take away a quarter. So our answer is negative u take away a half, all squared, plus a quarter. U, remember, is just this, so this bracket could equal 0, so the largest, or the maximum value is a quarter. Okay, so that's that part. Next, hence write down the maximum value of this. Well, this is exactly the same as that, it's just all been raised to a power of 5, so it's just going to be 1 over 4 to the power of 5, which is, I don't even know if we have to work that one out, but 4 times 4 is 16, 64, 256, 1024, so 1 over 1024. Okay, and then finally, find the maximum value of this. Well, we see that we've got 1 minus cosine squared, which we should know is a trig identity for sine squared. And that's also power of 4. And then we've got this function here to the power of 8. So this is going to be sine to the power of 8, 3x take away 60, and then this thing here, 3 take away cosine 150 minus 3x. Now, what you want to do in a case like this is you want to anchor one of these arguments, so one of these things. And what I mean by that is, let's say that 3x take away 60 equals p. Okay, so if 3x take away 60 equals p, then what we've got is sine to the 8 of p times by 3 take away cosine of, well, what's this going to be? Negative 60 take away p is going to be negative 3x. I want 150 take away 3x. So if I add 150 to both sides, I get 90 take away p equals 150 take away 3x. So therefore this is going to be 90 take away p. And we should see that cosine of 90 take away p is going to be the same as sine of p. Okay. So, just in case you're not convinced by that, imagine I've got cosine, which looks like this. And then what I'm doing is, so this is cosine cosine of x. If I move this 90 along, so 90 to the left, it's going to end up like that. So that's cosine of 90 plus x. And then if I swap x for negative x, that's a reflection in the x-axis, a reflection in the y-axis, which will end up looking like sine. Okay, if I just do this over here, it's a little bit messy, but it will end up looking like this. Okay, which is cosine of 90 take away x, which is exactly the same as sine x. So that's where that's come from. Okay, so I've got sine to the 8p, 3 take away cosine, 3 take away sine p to the power of 8. And we want to find the maximum value of this. Well, this is always going to be positive because of the fact that it's an even power. And this here, all of this, what we're going to want to do is we're going to really want to maximize this. So the maximum value anyway of sine to the 8p is 1. And that can happen when sine p is 1 or negative 1. And so we should see actually that if sine p is negative 1, then what we get is 1 multiplied by 3 take away negative 1 to the power of 8, which is 4 to the power of 8. And so that is the maximum value of that function.